There was a somewhat of a disgruntled 250 student, and I had a WWE style body slam, and TV was just a casualty of war. That's what it comes down to. All right, let's see. Did I leave errors in this guy or no? All right, so here's our register screen, right? We have a whole bunch of registers showing up in here, and we name these dudes something reasonable, right? Here's our register screen. Yep, here's all of our registers. So we created a big array of our register edit texts to hold all of our individual registers. And then I think didn't we write a quick loop last time to prove that we could write to them, making sure that they were all like legit or whatever. All right, so now we want to have the ability to globally save the contents of these guys, and at the same time probably fill these registers up with the current values of them, right? All right, so we already have this thing AR map, which kind of acts as a singleton in and of itself. You could certainly use it that way. What I would probably do if it were, let's see, well, we already have our registers up there as a string array. So with that in mind, I'm probably going to just use that. So we already have that's why I gave it to you as a starting point, right? Yeah. Yeah, so here's your, so I even gave you the singleton, I gave you the place to store it. Oh my gosh. The complaints about this assignment were completely unfounded. This is completely unfounded. So what I'll do is under this init, we even filled it up. Oh, these are the names of our registers currently. Okay, so I'm going to go ahead and create, we'll just do this as a parallel array example. Then we'll upgrade it from there, maybe into an object type thing. But I'm going to create a second array, static. I'm going to make it an integer array, just so our values, we can numerically do stuff with them more quickly. You could make an argument that you wanted a string array or you wanted an int array. At the end of the day, the values that will live inside of our registers will be numbers, right? Even though when we put it into our edit text, it's going to come out as a string. So I'm going to go ahead and store it as an int. That way when we do math, we can just use the values as opposed, and then we'll just change it back to a string when we need to put it into stuff. So I'm going to store this guy as an int array. We'll call this guy register values. And he'll be a new int array of size 31. All right. And then what I'll do is I'll go ahead and initialize this to a bunch of zeros, because that's what we kind of have our registers set at initially, right? Everything was a 0. So in my little for loop here inside of a init for AR map, I'm going to say AR map dot register values at bucket I is equal to a 0, like that. All right, so now that guy has all of those things. Now maybe instead of 32, it would have made, because we are technically, so this only has 31, so this is 0 to 30. Are we using a init yet? Because there's 31. This is a 31 bucket array, so we can't be using a init yet. Yeah, we're not. So we wrote a init to work a certain way, but we didn't actually call a init yet. Right now, a init would actually break because I have my arrays are 31 buckets big, because we're kind of we omitted the 0 register. You got to have hard coded 32 in here. So really, I want to have this guy set to AR map dot registers. You can pick any of those 3 things. Dot length. That'll go through and do it the right number of times to fill it up with all my register names or fill it up with all of my register values. So we just filled up our array with the right number of, this would be x0, x1, x2, x3, so on and so forth. This will just keep saying 0 for the value over and over again when we originally initialize it. All right, so that's all we do inside of AR map. Now, what we'll go ahead and do is we'll go over to our register screen and we're going to write the code. I'm going to go ahead and create a little function here. We'll create a private function, void. We'll call this guy fill registers with current values. We'll just really spell it out there, but that's what that guy does. So we want him to spin through our global array of values, register values, and fill in the same places in our register ETs with the string version of that value. So we'll say for int I is equal to 0, I is less than AR map dot There's an AR map. Where's my AR map? Yeah, AR map dot registers. Why is this guy? Oh, did I make it private? Yes, I made it private. So we're going to make this guy, we can keep it private or we can give ourselves a, I'll make it public. So I'll just make that guy public for right now. We're going to be updating the way it's going to work anyways. So that way I have access to it. So in here we have AR map registers.length, I++. What we want to do is we want to go through all of our register values, and actually this should probably be, even though they're the same name. I need to make the values public as well. So register and register values both have the same length, so it would have worked anyways, but we might as well use our register values length just so we keep our mindset on what we're working with. So I'll go through all of my register values. So my register value at bucket 0 is the value that we want to put into register ETs at bucket 0. My register value at bucket 1 is what I want to put in register ETs at bucket 1, so on and so forth. So I'll say this dot, the register ETs at bucket I is dot set text. So I'm going to set the text for that particular guy. And what am I going to set it equal to? I'm going to set it equal to AR map dot register values at bucket I, which is an int. And I'm going to concatenate that onto the empty string to give me the string representation of that guy. All right, that makes sense? So when I first come onto this screen, after I grab all my registers, I'm going to go ahead and call this function. So this dot fill registers with current values. So that will read from AR map the current values of all my registers, which I'm going to have initialized with zeros right here, because that's what we want all our registers set at the beginning. So that guy will get all filled up with that. All right, so let's make sure that it does that correctly. Actually, just to test this real quick, I'm going to actually change this from a 0 to a 3, just proving that my copy over is working. Okay, so I'm going to initialize them all to 3s for no good reason other than in our edit text, the current value is 0, and we'll see it change to a 3. All right, now we do need to make sure that we do call armap.init. So we wrote this last time. So we're going to call the init function for our AR map, which is going to set up all of our values here. So inside of main activity, I'm going to go ahead and comment this guy out for a second. I'm going to say armap.init. So that'll go through and it will set up my register names, which I'm not actually using right now for anything. It'll set up my register values, which I'm just going to default to 3 so we can see it work on the next screen. And then it's also doing the decimal to 5-bit binary thing for the names of all my registers that we're going to use later on when we actually write the get the ARM code, the assembly code. All right. So inside of main activity, when that main activity is created, we'll go ahead and on a one-time basis, we'll tell our AR map to initialize itself, which will fill everything in. Then when we hit the registers button, it's going to take us to that register screen. What does the register screen do? It comes here. On create for this guy, we'll go ahead and map, grab all the registers from the interface. And then I'm going to call my function I just wrote called fill registers with current values. And what does this guy do? He just spins through all of my register values and sets the text in each of my edit text equal to that value. So if this works, I should see a bunch of 3s in there on that second screen. So that proves how we can get to the screen. Then we're going to make our save button work so that we can change one of those values to something else, hit save, go back, come back, and then see that that value was remembered. So there's my register screen. There's all my 3s. All right. So it's now loading from a saved location. That makes sense? All right. So now I want to be able to change those 3. If I want to be able to do something like this, I want to be able to say that guy's a 2. Then I want to hit save. And when I hit save, it'll save it. And then I can have it. I can then click go back if I want to. I'll show you in a few minutes how we can do both of those in the same kind of move. But I'll go ahead and hit save. Then we can hit back. And then when we go back into registers here, we'll see that 2 sitting there. That's our goal. All right. So real quick, since we've proven that that part works, I'll go ahead and not initialize them all to 3s anymore. I'll initialize them to 0s. Make sure that's, that's a better starting value, right? So when I hit play here, you'll see that we have a bunch of 0s on that second screen now. There's all my fancy schmancy 0s. All right, so now we're going to write the code in our save. And this is inside of, there we go. This is inside of my save button pressed. So when I hit the save button, what I want to do is I want to go through all of my registers and copy the current value that's in those edit texts, the integer version of the current value of my edit text, into my global AR map register values. Make sense? And for the sake of the homework assignment, we can just assume that they did put values in all the edit text. They didn't leave one blank or something like that. We can do all sorts of error checking and stuff if we wanted to. So then what I'm going to do is I'm going to go ahead and I'm going to say, so for int I is equal to 0, I is less than this dot the register ETs dot length. So I'll go through all my register ETs. I plus plus. All right, and I happen to know that my register ETs length is the same as AR map dot register values length. Those are parallel arrays. So I'll say AR map dot register values at bucket 0. This guy is expecting an integer. What integer am I going to give it? I'm going to give it the this dot register ETs at bucket I dot get text. Okay, and that's going to give me something called an editable dot toString. That's going to give me a string. What do I want to do with that string? I want to convert it to an integer. So that's integer dot parse int. That dude. All right, so I'm going to use this little tool here, integer.parseInt, which allows me to squeeze the integer version of a string. Kind of think about like juicing a string. Don't you ever think about like programming stuff like in weird ways like that? I think it makes it easier to remember. If you think about juicing an orange, you extract the juice from an orange, right? If you juice a string, we're extracting the integer from the string. It's just a very special juicer. None of you like me.
I just think of my socks coming apart whenever I think strings.
You think of your socks coming apart?
Yeah, a little string that's always hanging off. It's always really annoying.
All right, so there's my AR map, register values, bucket I. I'm going to set that guy equal to the integer version of the value that's in the current edit text of this screen. Okay. And then just for Maddie, we will make toast. So we're going to go ahead and how do I do a toast? Toast.make text, this context. We'll just say save ... So expect something else from me? Dot show. Oh, I need to give it the length of time, right? Toast.length short, something like that. So toast make text, give it this context, say saved, and we'll do that for a short period of time. That will actually show it. So it'll just like ping up on the screen, saved, right? All right. So we'll hit play. Somebody should get a bunch of zeros. We'll change one of them to a 2, or we can change as many of them as we want to a 2. So there's my zeros. We'll just change that guy to a 2. I'll hit save. Oh, did I not hook up my save button pressed? So this function does what it's supposed to do right now, but I need to go to my register screen. I need to click that save button, and I need to set his on click to call that function. Then I'll do this. Here's my 2. There's a little toast there, Maddie. Missed it. Then I'll hit back, go back to registers, and there's our 2. I change this guy to a 5. Then I hit save. Then I go back, and I come back into registers, which is loading a brand new thing. There's our 5, and our 2 still there. All right, so we're remembering register values between screens now. So was that was the homework assignment? All right, so not too bad. But I don't think I actually said you had to do it on this side. I said you could just do something inside of main activity to like just spit it out or something. I give yourself a button that says prove they worked, and just spin through and print them out to logcat or something like that. So you could have done something like public void test button pressed UV, and we'll go ahead and we'll say for int I is equal to 0, I is less than AR map dot registers dot length I plus plus, and we'll do a system dot out. I think I showed you the format thing before, didn't I? We've done that in here. So instead of println, we could do format. So I can do system.out.format, and what I'll do is I'll print out a register name, followed by maybe a dash, followed by a register value, and then I'll kick it down a line. And then the values I'm going to put in there are going to be armap dot registers at bucket I and armap dot register values at bucket I. All right. So this is going to be a click for another button I can put on my main screen. So when I come back there, I can click that button and it'll spit out to logcat all of the values that are in there. So let me go ahead on this. My right eye right now is basically completely blurred. That's good. All right, I'll just throw another button in here real quick. Perfect. Just have this guy say test. We'll set his on click to be this test button thingy-majiggy. All right, then we'll go ahead and hit play here. Click on registers, go in here and change this guy to something. We'll hit save, make toast. All right, then we go back here. I can hit my test button and then come down here and look at logcat. And there's my bucket. 0 is a 2 right here. So prove that it was saved. So you could have just done something like that, even though it was, I don't know, I think easier just to fill the other screen back up, but whatever. This would have been sufficient as well. All right, so questions on the assignment. So the real magic there was this AR map singleton dealy thing where I gave myself a couple of public static variables that are owned by AR map. That way I had access to them from both sides, from the register screen, as well as the main activity, as well as any other screen in our application, since these guys are now public and they are static. So I can always say AR map dot whatever. Remember last time we wrote this little init function. So what we did inside of main activity, when we first load our program, we call armap.init, and that does any setup that we want to have within ARMap. So we can throw all sorts of stuff in this little setup program here. Okay, so now we have values that are representative. Well, now we have the ability to see all the values of our registers, and we have the ability to modify and save the values of our registers, right? Now, when we hit save for a register, do we want it to go ahead and automatically go back to the previous screen? Is that something that we wanted to have do? All right, so a couple different ways we can pull this off with Android. I come into register screen. After I do my toasty thing, I can say this dot on back pressed. So I can just call upon that function that automatically gets called with on back pressed. I do wonder though whether the toast thing will stay on the screen. I might need to make a, see, is there a toast dot make text that allows me to, that takes a duration. What's this guy? Well, let's see if he just stays on the screen. That way we know it's saved, but otherwise we don't really need the toast. We can just go back to the screen and that assumes it was saved. So let me show that here. Then I'll show you an alternative to this. Oh. Click on registers, change this guy to a 2. I'll hit save. It went and did this. Ah, the little toast stayed up there. So cute. All right, so it took us back to this screen. All right, so what does this prove to us? So an activity has built into it an on back pressed function. This function is the function that gets called when you hit the little back button here, this guy. If I go in here and I hit this dude right here, that on back pressed function gets called. And what does he do? Well, he doesn't do any logic. He just dismisses this activity and shows you the previous one. Closes the current activity and takes you to the next one on the stack. Okay? So now you're back here. So now if you wanted to, I mean, we could say that, well, you know, the save button is kind of ugly. We don't like having this giant save button there. So instead what we can do is we can override the on back pressed function. So we could say public void on back pressed, like that. I need to check something here real quick. This dot on back pressed. Yeah, there's usually, I think I can actually do this and it'll help me complete it. Can I do at override and then on back pressed? No, guess not. Thought there was a shortcut for doing it, but we'll just type it public void on back pressed. And then what we'll do is we'll take all of our logic that we did in here. We'll leave the save button on the screen for right now. Okay, so now this code will get called when I actually hit the back button. Now this code currently has a bug in it. What's wrong with this code right now? I think public's gonna be okay.
Will it get called on other screens when we get the back button?
No, because it's going to call the current activity. So this guy is an instance method of the current activity, right? So this dot is the instance of register screen, where in the previous screen it'll be this dot main activity. It'll be this will be an instance of main activity. Go ahead. Yeah, we got an infinite loop here. Why? I'm calling my own on back pressed function that I overrode. So what does this code do? It goes through, saves all my register values, makes some toast. Maddie makes toast. Yeah. Then it calls his own on back pressed. What does that guy do? Saves all the registers, makes toast, calls his on back pressed, blah, blah, blah. So whose on back pressed do I actually want to call here? So I actually do want to go back to the previous screen. Okay, and who knows how to do that? My parent knows how to do that. The on back press that I got from my parent. Ooh. So click on registers, change this guy to a 2, hit back, there's our saved, and now we're back in here. When I go back in, it saved it. So if we do it only with the back button like this, what we've done then is we've made it so that we are not allowed to not modify our registers. We're not allowed to like decide like, oh, I didn't actually want to do what I just did. Does that make sense? So I'm not sure that makes that much of a difference to us. Course a piece or something. But you know, right now we have a save button that will do what we want it to do. And our back button does the identical thing to our save button. When maybe we decide we want our back button to just do the default back thing and not do any saving. So you can pick your poison. I would say it probably makes the most sense for your on back pressed not to. Here, I'll leave it in here and comment it out just so you have it for like notes or something. But what does the save button do? It actually does the saving and then acts like we actually did hit the on back pressed. Now, why is it okay for me to say this dot on back pressed here? Or could I say super dot on back pressed? They both will actually work. But why was it okay for me to say this dot on back pressed here when I wasn't able to say this dot on back pressed up here? Somebody other than Emma. Go ahead.
You didn't override it, so it's just calling.
Yeah, I didn't actually override the on back pressed. So when I say this dot on back pressed, it is calling the one that I inherited from my parent. Make sense? So in this particular case, this dot on back pressed and super dot on back pressed are synonyms. Because this dot on back pressed is the version of on back pressed I inherited from my parent, which is super. So super's on back pressed is the one that they gave me. Okay, so now my save button will do the saving and also take me to the previous screen, as opposed to the back button just taking me to the previous screen. Make sense? All right. Okay, so now we have a way of storing our registers that we can then later use in here if we want to do an add or something related to the current value of registers, right? Now those guys are stored somewhere. So I think when we look at AR map here real quick. So here are the various instructions I have available right now. So a normal add has 3 parameters, right? What are the 3 parameters for an add? This is in ARM assembly. So an add takes 3 parameters. What are the 3?
The register to store the answer.
Okay, so the register to store the answer in, and then the 2 sources, right? So add is, I'll just put it as a comment here. So we've add, we'll call this guy dest register, then source reg 2, source reg 1. It just happens to be the way they lay it out. So we're going to take source register 2, whatever value lives there, which is going to be some number, and source register 1, whatever value lives there, which is some number. We'll add those 2 things together, storing the result inside of our destination register. Make sense? All right, so now if we're thinking about this in terms of object-oriented programming, we're doing a whole lot of kind of parallel array stuff right now. It might make sense for us to kind of suck those things in and have kind of an array of registers where a register has a name and a value, okay, and then maybe even its mapped name, because we have those 5-bit version of our registers, right? So we're going to go ahead, do a little object-oriented stuff. So we're going to create a register object. So we're creating a new Java class. So this is not an activity or anything, just a plain Jane Java class, same type of thing we would have made inside of Eclipse. And we'll call this guy a register. And yes, I will add it to my Git repository. Whoop. Okay, and there's 3 pieces of information I want to store with a register. I want to store its private string name, private int value, and let's see, and then a private string, maybe bin name. Well, let's just call it binary name. I like that better. Very spell it out. Why do I need a 5-bit binary name for a register? Somebody who hasn't answered yet today. What am I talking about there? I don't want to dive too much into code without remembering why we're writing this code. Why do I need to store a 5-bit binary name for a register? Go ahead. Okay. Okay, so you're thinking about potential contents of the register. Yeah, no, this isn't used for contents. Go ahead.
Well, there's 32 32 registers, and the number of values 5 bits can store is 32. So you'll have one name for each register.
Okay, so one of our registers is X0, right? What's the 5-bit name for X0?
00000.
Okay, what's the X1? What's the 5-bit name for X1?
00001.
What's the 5-bit? Yeah, just like 31 times. Just go, 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 go. All right, so let me connect the dots with the book then for you guys. What's the name of our book? Zybooks. Thank you. And this is this class, right?
No, we're 275.
That really might not make a difference to me. Only you knew how oblivious I was to reality. It would be probably the same as you already assume, I'm guessing. What are you going to do? Instructions, right? Is that what we're under?
2.5 is one now.
2.5. Thank you. Representing instructions. Perfect. All right. So this guy right here. So this is an example of our add instruction, right? So in our add instruction, we have, for example, they're saying our destination register might be, actually, this wasn't our destination register. The destination register is the very last one in this case. X9 is represented by the 5-bit value 9. So that's our binary representation for a register that is X9. Because even though we like reading it as X9 or X8 or X13, whatever, because that's kind of a human readable thing, ultimately our computer is going to store instructions as a, well, how many total bits is this? 31 bits? 32 bits? 32 bits? With an 11-bit instruction, a 5-bit source. This is the shift, a 5-bit second source, and then a 5-bit destination. Make sense? So it needs to have a mapped name for those registers. So what we'll do is in our register code here, we'll keep track of those 3 things. What is the actual name? So we can even call this the human name. Human readable name. This is the human readable name for our register. This is the 5-bit binary name for our register. And then here's the integer value that actually lives in there. Whatever number we saved. Make sense? All right, so now what we want to do is we want to create a constructor for this guy. So this will be public register. This guy will take in why don't we go ahead and just have him take in the readable name, right? And then he will go ahead and default the 5-bit name and the, he'll calculate the default, the 5-bit binary name, and then set the default value to 0. So he's going to take in a string, human readable name, like this. And we'll go ahead and set this dot human readable name equal to human readable name. Next, we need to split our human readable name. We need to get the X and then get the rest. So we need to get the integer version of everything but the X. Because we know all of our registers are going to come in looking like this, either X1 or X13, something like this. And what we really need to do is we need to get these two split apart. So I can just see the 13. Because then I want to turn that 13 into a 5-bit value. All right, and I think in AR map, we wrote the function to do that. Decimal to 5-bit binary number. So we have a nice little tool here inside of AR map that goes ahead and I can toss it an int, and it'll give me the 5-bit representation of that int, which is exactly what I want here, right? All right, so our first step is if I have a string, and this is for somebody who hasn't answered yet today. Who hasn't gotten a correct answer yet today? Go with that route. If I have a string that looks like that, how do I get just the 13? And we'll even start the simple case. From that, how do I get that? From x13, how do I get just the string 13? Go ahead.
If you were converting from, what is it? From string to int, you could just choose to look at the position after the first one.
Okay.
And just ignore.
So I'm going to ignore bucket 0.
Yeah.
Okay. So how can I write that code? They got the easy way and the hard way, depending on whether or not you know about the existence of the easy way function. Both of them aren't that. Neither of them are that hard.
There's a built-in and split the string. The string. I forgot. I used to run into it.
Okay. There is a split function. I think the split function you're thinking about, though, splits on a regular expression. So you can say I want to split it on commas or something like that. In this case, we have no spaces. But as you pointed out, we just want to ignore bucket 0. So I could just build this guy, right? I can just write a quick little for loop that starts at bucket 1 and goes all the way to the end. Builds up that string and everybody's happy. So let's just write that real quick. And then I'll show you the alternative. So we'll say, we'll say string answer is equal to the empty string. For int I is equal to 1. I is less than human readable name dot length I plus plus answer plus equals human readable name dot char add I. So that'll build for us a brand new string that is everything except bucket 0 of the string that was provided. Right? Everybody's happy? Okay. Or we could have just said answer equal to human readable string dot substring 1. Give me everything from bucket 1 to the end. Okay, so this guy right here and this guy do the same thing. Life will go on with whichever of those two you choose. All right, so if you don't necessarily remember that there's a substring, typically substring is something that most languages have. So that might be something you can kind of almost assume there is, and then you just do a quick Google search, Java substring, and it'll show you the syntax and move on and do it. Otherwise, if you don't want to waste your time, just write a quick for loop and go. All right, so we're going to call this guy reg number. All right, so that's our actual register number that we have for this guy. Now, you know what? I don't know that I'll actually need that, but you never know when it might be helpful to have the register number. So I'll go ahead, and since I'm doing it anyways, why don't I just say private int register actually, let's call this decimal register number. And we're going to call this 5-bit binary register number. So those two are kind of mapped together. All right, so this dot that is equal to, this guy is going to be that number as a string. If I want a string as a int, what do? Juice it. Integer dot parseInt, and that's the string I'm parsing. So give me the decimal numeric value of everything except the X in my register name. Now this does presume I'm going to pass in legal register names. All right, so there's my decimal register number value. Then I want to go ahead and get the 5-bit value. So this dot 5-bit binary register number. That guy is going to be, we already have a function in AR map. Now this function is called decimal to 5-bit binary, but it's currently set as private. I'm going to make this guy public so I can access that from my register object. So AR map dot decimal to 5-bit number. What's decimal value? This dot decimal register number. So this will convert that decimal number to its 5-bit string representation, and I'll set my 5-bit string representation to that. Finally, this dot value will start off at a 0. Make sense? All right. Now, even though the official ARM instruction set has different size registers, I think the book's leg instruction set, does it just have, what does it have? Is it 32-bit values? I think all the numeric registers are 32 bits, pretty sure. So we might want to end up storing that in here as well. That way we get the nice binary representation, because who wants to look at stuff in decimal? So human. We don't want to do that. All right, so we'll leave it like this for now, but we might want to come back. And it's a good thing that in AR map, if you remember, we did give ourselves a nice decimal to n-bit binary value. So I could toss it a 0 and have it give me the 32-bit representation of 0. So we got some nice little power tools here for doing some of that stuff that we wrote. Okay. Now, one thing I do want to keep pointing out here is, notice that things are starting to feel a little bit complex because we're writing all these little tiny power tools. But look how simple decimal to 5-bit binary is. Because what we really wrote was this guy right here. That's our code that will convert any numeric value to its equivalent n-bit binary number. Does all the padding. So by us writing this one little power tool here, we can use it all over the place for doing different things. That makes some sense? All right, so kind of keep in mind we're looking at a project here we're kind of organically growing it, but understand that none of the individual pieces are all that complex. So the hard part that we're really having to deal with here is the problem-solving piece and saying, oh, well, what do I do next? Then what do I need after that? Then what do I need after that? The actual code writing, if we give ourselves a little tiny problem, like, oh, I need to solve the problem of converting a number to a 5-bit representation, that part's not hard. Knowing that we need a 5-bit representation, that's where many of us might be currently kind of hitting our sticking points. All right. Which is why writing larger applications like this is beneficial as you get farther and farther in school, because if your only competency when you come out of school is that you can write a function that does this or a function that does that or a function that does something else, things are going to get pretty sketch when you get out to your actual job and they want you to write an application that does something with lots of moving parts, even though, one of my older mantras, I learned it from somebody else, so I didn't come up with it, is the idea of all hard programs are made up of a bunch of easy parts. So if you look at the source code for Windows, you're going to see for loops, you're going to see ints, you're going to see all sorts of stuff that are very, very familiar to you. You're just going to see them in bulk, okay, with lots of function names and probably poor documentation. Yeah, it goes for the par for the course. All right. So instead of a register, we're just storing 4 fields, right? So this is kind of our replacement for 4 separate arrays. So we've taken 4 parallel arrays, we've sucked them into a single object, storing 4 fields, and now we can just have an array of registers that has all the information about every individual register. Okay? So I'll go ahead and give myself getters for all of these guys. I won't need to change the human readable name. I won't need to change the the register, decimal register number. I won't need to change the 5-bit binary register value, but I will need to change the value of this guy when I hit my save. So I'm going to go ahead and give myself getters for everything, and then a single setter for my value. And built into Android Studio, I can right-click. I can say generate, and I want to generate getter. Actually, I think I can say getter and setter, then specifically choose the ones I want. No, I can't. So I'll just do all the getters and I'll do the one setter. So I'll generate getters. I want getters for all of these dudes. So just highlight them all, hit OK. There's all my getters. So that gives me my ability to read those private fields. And then I'll give myself my one setter. So right click, generate, setter, and I want to be able to set the value of this register. So I'm going to use that by my save function. All right, so there's my set. Make sense? All right, so now I'll go back to AR map and let's clean that up some, get rid of our bucket of parallel arrays here, and instead have a single array of registers. So I'm going to say I'm going to have a public static register array. We're going to call this guy registers, even though I know we already have our registers. We'll deal with that here in a second. In fact, actually, let me just get rid of all these guys. So we no longer need register. We no longer need register values. We no longer need bin map. So we'll dump those. So now we have registers, and this guy will be a new register array capable of holding 31 registers. All right, then we're going to go through and we're going to set our registers array equal to, now remember, here's our register. All a register takes in is the human readable name. So I'll pass it x0. It'll internally do all the other magic. It'll set its name to x0. It'll set its number to 0. It'll set its a 5-bit value to the 5-bit version of 0, and then it'll default the value to 0. X13 will set the human readable name to X13. We'll set the register number to 13. We'll set the decimal value to the 5-bit, or the binary value to the 5-bit representation of 13, and we'll default it to 0. Make sense? This guy does all that magic for us. So inside here, I'm going to get rid of these two guys. I'm going to say we're going to set inside of registers at bucket I a new register with the human readable name of X plus I. That makes sense? So now, over here in our register screen, I'm getting all my edit texts. Then I'm saying, okay, I want to go ahead and fill my registers with current values. My current values used to come from this array called register values, but now it's going to come from my array of registers. So I'm going to go through all of my registers. For each register, I'm going to set the text equal to armap.registers at bucket I, which is a register object. And I want to get from that register object the current value associated with that register. Dot get value. And that guy is an int, so I'll go ahead and concatenate it onto the empty string to get the string version of it. Make sense? Lastly, for my save button, I'm no longer dealing with my register values. I'm instead saying AR map dot registers at bucket I, so that's going to be an actual register object. I want to set that guy's value. Dot set value to what? The integer version of the string that's currently in this get text. That guy. That makes sense what I'm doing there? My logic hasn't changed. I've just done this in a more object-oriented way. Before I had well, actually I had four parallel arrays, right? 4 parallel arrays just laying there. Kind of messy, right? Kind of like a pile of wires. Think back to 200. Big pile of wires. Now what do I have? I got a register object. Inside that guy, if I pop it open, it has 4 pieces of information in there. I can extract all 4 of them, and I can change one of them. That make sense? All right, so we haven't improved our logic. We've improved our object-oriented design of this guy, which should make our life easier in the future. Because going back and making a change to our save functions wasn't difficult, right? Once we had our register written, that wasn't a big deal. And if you go into register, is this guy all that scary? The only part of this we even wrote was this. 4 variables and then initialize them. All this other stuff was just the generated getters and setters. All right, let's make sure we didn't break anything. Never had an error yet, but first time for everything, I suppose. I must be using my register value somewhere. Oh, this is my test button. We don't need test button anymore. I'll go ahead and dump it from our screen here too. All right, so I click on registers. There's all my current registers. I'll change this guy to a 2. I'll change this guy to an 8, just for, I don't know, completeness or something like that. I'll hit save. It does its saving. It goes back here. I'll go ahead and hit registers again. There's my 2. There's my 8. So still works the way it worked before. It's just a little bit more organized. We cleaned up our room a bit. Make some sense? All right, so before we go any farther, are there any questions about what we did here? Okay, because we're going to have homework assignments associated with these things, and if you're completely lost to these objects, then those are going to be problematic for the wrong reasons. Okay, I want the assignments to be challenging, but I want them to be challenging for the things I'm trying to challenge you on, not that, oh, I don't know how to use this object. All right, go ahead.
Can you just explain what the human readable name variable is again?
Yeah, so maybe it'll be easiest if I just put like next to it kind of examples. So this might be like X13. That's the name of my register, you know, X3, X13, X27. Whereas the decimal register value, what's a 13? That's 1, 2, 4, 8. So that's going to be an 8 plus a 4 plus a 0 plus a 1.
Wouldn't that be the binary?
Oh, yeah, thank you. 1, 1, 0, 1, like this. This guy would be, it's an int, so this would be a 13 there. I wrote 13 here. It's X13, so this guy's 13, and this is the binary version of 13. And then this guy is the current value stored in the register.
Which is 0.
Which is 0 when I first start it. But when I go through and hit save, now anything is fair game, right? As long as it's a number. Otherwise, our program crashes. And why does it crash? Why would I program crash right now if I try to store something in a register that's not a number? Yeah. Can't juice a question. Oh, it won't even let me do it because it's a numeric field. Oh, look at that. Built-in. Can I put a comma? No, won't let me do that. How about a 0, comma? No. Oh man, that makes it. I wonder if that'll parse. It starts with a 0. Will that parse? It does. But it probably goes back to, I took the 0 off. Man, we can't even break it? What fun is that? Here, it'll be broken now. It'll be broken now. I'm gonna turn nothingness into an integer. Yeah, so you can't juice nothing. There you go. Can't juice nothing. You don't like the juicing analogy? It's like fun, right? This class does not seem as entertained as they should be. All right. Well, I mean, this row seems actually fairly entertained, but the rest of this audience, is not so great. All right.
I think it's just because it's election day. No one's entertained.
Really? I don't know. This is pretty much the equivalent look I usually get. All right, but does that make sense? What those, Maddie? Does this make sense? What those fields are for? Okay. All right. Other questions? All right, so we're now having saving on that side. So let's say that I want to be able to, because in order to do an add, a normal add, do I need to have memory? Do I need to have a mapping for memory or anything? First time that comes into play if I want to implement add immediate, right? One of the immediate things, because then I have to kind of get a value stored in memory, get to it, bring it back in, something like that. Actually, not even for add immediate. Add immediate would just require a secondary value, so I don't need it for add immediate. But I would need it for loads and stores. Yeah. All right. So right now we can implement add to do something. So you told me, you told me that add takes 3 parameters: destination register, source register. Doesn't matter if you call it 1 or 2. For add, it's the same. Subtract, you got to be careful. But but for add, it wouldn't make a difference. So we're going to say source register 2 followed by source register 1. So on our main screen here, we can put a little string. Maybe an edit text that allows us to type in a ARM function. So I can say like add space x0, comma, x3, comma, x5. And then I can say run. And that guy should actually do the addition, storing the result in the right place. I should then be able to go look at my registers afterwards and see that it worked, right? So let's get some of the pieces on here. So we're going to go on to our main activity main thing here. All right, and we have our vertical linear layout guy here. I'm going to go throw another horizontal one beneath this to give myself like my edit text. Actually, why don't I just give myself a whole line for my code and then a button for run. Make it cleaner, gives us plenty of room. Let's do that. Plus, less me having to organize layout stuff. So I'm going to, now we want this guy to be plain text, right? We don't want to lock him into numbers because they need to be able to type something like add x0, comma, x1, comma, x2. They need to be able to type something along those lines. So I'll throw a plain text guy in here. Oh, see, look, I even dropped it in the wrong place. There we go. Plain text guy in there. Now we need to make our horizontal linear layout here. This guy's height is currently match parent, so it's shoving everything else off the screen. So I'm going to change this guy to just say wrap content. So now it just wraps my buttons. And then I have my edit text right here. And that guy is looking extremely funky. I'm going to dump this real quick. And I'm going to add it again. Actually, having it at the top might make more sense anyways, right? Above before our registers. All right, so I'm going to put in as a hint, enter ARM instruction. All right, and then I'll take the text out of it. So it says enter ARM instruction up there. All right, and I'm going to go ahead and center it just because I think I like that better. So I'll set the gravity of this guy to be center. So there's my edit ARM instruction there in the middle. All right, then I'll go ahead and I'm going to put a run button underneath that guy. I'm lost. There we go. Actually, let's call it execute. Doesn't execute seem way more threatening than run? It's like it's like an aggressive word, isn't it? Yeah, like that.
You want more computer-like.
Old school computer-like, yeah.
Yeah, like just imagine like text-to-speech saying execute.
Yeah, well, like when you run, that's like an interpreted language.
Right.
Kind of sluggish, kind of smooth, whatever, but execute. Binary, right to the CPU, stuff's happening. All right, I like it. All right, so we're going to write I'm going to write a method for this execute button. And I'm going to, well, here, let's just do this. I'm going to go into main activity, public void execute button pressed UV. All right, so this is the dude that will get called. And what should this guy do? He is going to read the instruction from, and I'm going to go back into my activity main here, and I'm going to change the name of this edit text. Instead of just edit text 2, I'm going to call this guy instruction ET. This is the instruction edit text. Go back in the main activity. So read the instruction from instruction ET and appropriately execute it. See, those are the things that happen there in the okay, appropriately execute it. So we're going to read the instruction from the instruction edit text and then appropriately execute it. So for example, if instruction ET contained add, and you can assume it's all uppercase or something like that. I don't care what assumptions you make. You don't have to error check the inputs. So if you say add x0, x1, x2, something like that. If that was the instruction, your code should grab the value from x1 and x2, add them together, and store the result in x0. That makes sense? All right, you only need this to work for add right now. So even though down the line we want it to work for a lot of different instructions, it only needs to work for add right now. So if you type in add, so if I type in something like add x0, x1, x2, and then I hit execute, it should do the work, and if you wanted to do a little toast thing, you could, saying done or something like that. Okay, then once it's done, I should be able to click on registers. So, as an example, if I go and I put in X1, I put this guy in a 5, and I put in X2 a 3, I think I can add those together. All right, then I hit save. So now those guys are saved. So I have a 5 and a 3 in X1 and X2. And I execute this, it's going to get a 5 plus a 3 is an 8. It'll store the result back in X0. So when I go and hit registers, I should see an 8 there. That it accurately did the math. That makes sense? What I'm asking you to do? All right. So let me go ahead and I will commit this. Ready for add instruction test. Do a commit and push. Commit and push. And then we'll throw this up on Blackboard. Oh, yeah, what was that thing again?
The career night.
Oh yeah, I'll bring it up here in a second. So I think Professor Josh Locklear the other day announced on Slack, it was in the general channel, I think.
Yep.
Yeah, CSIT students, the Batterman School of Business is hosting a career night on Wednesday, November 14th, starting at 5 p.m. There will be a number of employers in attendance, including FIS, Baird, and U.S. Bank. Several employers have expressed an interest in connecting with CSIT students. Specifically, this looks like a great opportunity for you to get your name out there with some major employers in the region. So you will need to RSVP, so look at that career night poster that's in there to make sure you connect to the right people. If you go to that and send me a picture of you at that thing, I'll give you another extra credit token. Okay, so that is Wednesday, November 14th at 5 p.m.
You know how late it is?
I'm going to guess no later than 7. It might only be like an hour. Yeah. But I'm not positive. Let me pop open the
It doesn't say anything.
oh, it doesn't say anything in the poster. Maybe you can ask them when you message them.
Okay.